On Wednesdays, we're pink the second funniest day of this month, the February 24th, haha. Okay, you guys will be able to identify and use special products of binomial section 6.7. Okay, and this is also our last section of the chapter like we talked about on Monday, meaning that we're going to be reviewing next class, and then potentially, yep, and then after that, we will be testing next Trooper Tie Tuesday, okay? So, special products, okay? X plus 2, what's this X plus 2? What's happening to it? It has an exponent of 2, okay? So, it's being squared. Now, here's the thing. When we saw things before, when we saw the exponents before in the outside parentheses, we distributed them. Now, in that scenario, we had multiplication or division going on inside. So we had like a 3xy, don't write this down, squared, all being squared. And we distribute and say, okay, well, these were to the first. And so this is now like 3 squared, x squared, y to the fourth. And then we call that 9x squared, y to the fourth. Does that sound familiar at all? I hope so, because it was back in chapter 1. Okay. Now, here, on number 1, we have a slightly different setup. Can anyone tell me what's slightly different on number 1? Okay, Emily. We have addition going on inside the parentheses. Okay, so that's slightly different, okay? Now, if we were to distribute it, don't write this part down, okay? If we were to distribute, we'd have x squared plus 2 squared, which would be x squared plus 4, correct? Okay, let's look at, if we go back to what squaring actually means. What does it mean at its core to square something? To multiply times itself, right? You have two of that thing multiplying together. So you have x plus 2, two of them multiplying together. Now when we see two of these written out together, is that pretty similar to what we saw in our homework? Yeah, I think so, okay? And that's why I was getting at saying, hey, this is going to be very similar. So we would go through, and what do we do in this scenario? Yeah, we go through and multiply everything in the first, everything in the second, or FOIL is an acronym we use for that. Distribute everything multiple times. So x times x is x squared. X times 2. Write this part in the orange and green down. Okay, write this orange and green down. I'll give you a second to get up to where I'm at writing it down wise. Okay, so at this point then, x times 2 is at 2x. 2 times x is 2x. And 2 times 2 is 4. And we go through and we say, okay, well, we're noticing those middle two need to be combined, but everything's still in the right order. So we have x squared plus, what's 2x plus 2x? 4x. Plus 4. Is that the same thing we got up in the blue a moment ago? It's not the same answer, is it? What's different? Then we're missing that 4x. We're missing kind of the middle term, we'll call it, because it's the term in the middle, okay? We're missing that middle term compared to it. So if we get different answers, does that mean they're both right? No, because this actually wasn't okay math. So we said before, if we got different answers, but with okay math, both answers were right, and they ended up being the same. But here, this blue, the one we did originally, was not okay math. And the reason why it's not okay math is because it was addition in the parentheses, not multiplication. So we cannot do that distributing like we did, or like we tried right before we started. We can't do that because there's addition and subtraction. So what we need to do is just write two of the parentheses and then treat it like a problem we've seen before. Questions on that?
I forgot to tell you it's Ellie's birthday.
Is it actually?
No, it's not. It's Ellie's birthday.
Raquel, is it your birthday?
No. Birthday's in August. Her birthday's in September. So
Okay.
It's close. Half birthday.
No, it's not even.
Anyway, all right. Yes, Emily.
What?
I thought you had your hand raised. Oh, you went like this. So I didn't know if it was like a shy hand raise. Okay. Anyway, continuing on. All right, on number 2, we have subtraction. Y minus 4 being squared. What can we do in this scenario then? Yeah, rewrite the parentheses, write 2 of them because it's being squared. So y minus 4 times y minus 4. And what are we going to do now? FOIL, distribute, however you want to call it, multiply everything in one times everything in the other. However you want to call it, it's okay. Y times y is y squared. What's y times negative 4? Negative 4y, very good. What's negative 4 times y? Negative 4y, the same thing. What's negative 4 times negative 4, Raquel? Negative 4 times negative 4. Positive 16. Okay. And what do we notice? Is this in the right order again? Yeah, okay. But what do we need to combine? Yeah, the negative 4 and the negative 4, those two in the middle. Okay. And what are those going to combine to be? Negative 8y. And that's our answer. Questions on that?
Oh, wait. Yeah.
Okay. Why don't you try number 3 on your own real quick? Don't raise your hand when you're done, though. Okay, we can write the parentheses again, right? Write 2 of them. X minus 3y and another x minus 3y. That's what squared means, okay? So now what do we do?
Use the x and times the other side.
Okay, distribute the x to the other parenthesis, yep. So x times x is
X
x squared, x to the power 2. X times negative 3y.
negative 3xy.
Negative 3xy. I love that you put that alphabetically. I'll do that as well, put it alphabetically. Okay, now we've done the x times everything. So what do we need to do next, Emily? Now the negative 3y times everything in the other parenthesis. Very good. So negative 3y times x is?
Negative 3xy.
Negative 3xy. Once again, love that you put that alphabetically. I'll continue to do that. Negative 3 times negative 3. Negative 3y times negative 3y.
Negative 9y.
Ooh, not negative.
Positive.
Positive 9y squared. Now, are we noticing it's the same 2 terms every time that need to be combined? Which 2 terms need to be combined every time here? The middle ones, okay? And they always end up being the same, don't they? Okay? That's something that unique that we'll notice whenever we're doing a parenthesis squared, okay? So whenever we're squaring a parenthesis, we're always going to have that middle term end up being the same because you're multiplying the same 2 things. You're multiplying a negative 3y and an x. You're multiplying a negative 4 and a y. You're multiplying a 2 and an x. So the middle terms are always going to need combined there. And it's always going to be in order, though. And so we can say, okay, we can use it to kind of help us and say, yeah, no problem. And say, okay, we're going to have x squared minus 6xy plus 9y squared. Now, a quick reminder that negative 6xy, you don't change exponents and variables when you add those, okay? Questions on that, the order, anything about it? Okay? Give me a quick thumbs up, thumbs down on how you're feeling about it. I want everyone's reaction here, everyone's answer for thumbs up, thumbs down, even if you keep it kind of close to your chest and more private, okay? I want to see a reaction from everybody. Thumbs up, thumbs down. Okay? Go and put those away again, okay? I want you guys to try number 4 on your own. When you have this one or have questions, go ahead and raise your hand. So on this problem, we go through and we write it twice again. So we have 4a plus 3b, and then another 4a plus 3b. Then we say, okay, well, let's distribute 4a times 4a is going to be 16a squared. 4a times 3b is 12ab. 3b times 4a is 12ab as well. And then 3b times 3b is 9b squared. Now, once again, because it was the same parenthesis both times, we have the middle terms need combined, and they're the same exact thing. So, and everything's in order. So we can leave it in the same order, 16a squared, and combine the 12 and the 12 and get 24, haha, ab plus the 9b squared. And that's our answer. Questions on that at all? Alrighty. Number 5. Have we seen a problem like number 5 before? Yeah. Are these the same parentheses at all even though? Like we have in the first few examples today? No, they're different in each parenthesis, okay? This is almost identical to a problem we would have seen on our homework, right? Okay? I want you guys to try this one on your own. Have it or have questions, raise your hand. If you have individual questions on it later, we can also go address those. So here, we're going to kind of just ignore that last one exists for a moment. And so we're going to have x minus 2 times x plus 3. So x times x is x squared. X times 3 is 3x. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. Then we have that x minus 4 just written afterwards still. So then I'm going to combine these in the first parenthesis. And we notice that 3x and negative 2x can be combined, but everything's in the right order. So we have x squared plus x, or 1x, minus 6. And then an x minus 4 in the next parenthesis. And if the underlining thing is something that helps you here, we can do that in that previous step. Now we're going to go through and distribute this x squared plus x minus 6 to the x minus 4. And some people prefer that the other way around, which is totally okay. So x squared times x is going to be x to the third. X squared times negative 4 is negative 4x squared. X times x is x squared. X times negative 4 is negative 4x. Negative 6 times x is negative 6x. And negative 6 times negative 4 is positive 24, haha. So then we say, okay, well, let's underline x to the third is coming first, negative 4x is coming second, negative 4x squared, and then x squared. Negative 4x and negative 6x are coming third, and that positive 24 coming at the end. Well, as we go through this, we might notice we get x to the third first, minus 3x squared, minus 10x, plus 24. So it's almost like it's kind of two problems in one. Questions on that at all? Okay. What do we think we might do on this third problem? Or on this last problem, excuse me. Okay. I see a lot of hands, and Isaac said already. Courtney, what are you thinking?
What I did is I took x plus 2, and I did it 2 times, and then I got an answer. And then I took that answer plus itself. So it's going to be the same thing, because you're going to have 2 sets of 2 on both sides.
Okay.
You know?
So I almost entirely agree with that, except for you said plus itself. I would say multiplied by itself.
Yes.
Okay.
And
So,
then I got the answer.
okay. And then, Emily, what were you going to say?
That's the same thing I did.
Okay. Did anyone do it a different way by doing it twice and then kind of just doubling and then copying that? What does it mean to have a power of 4? That you have how many of those? 4 of them. So it'd be literally like you just write x plus 2 times each other 4 times. And so there are a couple ways we could approach it. We could do a very similar way to the way we approach number 5. Do the first 2, ignore those last 2 for a moment. Get your answer for the first 2, then incorporate the third. Get your answer for that, then incorporate the fourth. Okay, and kind of make it like 3 problems in one. The way I would personally do it would be kind of what Emily and Courtney are saying here of multiplying these first 2 together. X times x is x squared. X times 2 is 2x. 2 times x is 2x. 2 times 2 is 4. And then saying, well, what's that second set of x, and then we can do the same thing with the second 2 sets of parentheses, x plus 2 times x plus 2. But is that going to be different than what we got the first time? No, because it's literally the same multiplication problem. It's the same parentheses again. Now, if you made a mistake on that first one and you just copy it down, what's going to happen? You're going to make the mistake twice, and it's going to become even worse, right? Okay, so it might not be a bad idea to double check you're doing it correctly, but we did do it correctly here, so we could just write it again and just say, okay, well the next 2 parentheses would also turn into the same exact thing. Any questions on why that's the case or what we did there? Any of that? That would be a good time to ask that. Okay. Because regardless how many times you do x plus 2 times x plus 2, you're going to get the same thing. So now we go through and combine. Well, in that first parenthesis, what can we combine? In that first parenthesis, what can we combine? The two x's, right?
So what does that mean?
And that can be x squared plus 4x plus 4. And that's going to happen. That's going to happen to this, the second parenthesis as well, won't it? The same thing will happen there. We'll get x squared plus 4x plus 4. And now what would we have to do? Multiply these. And is this like another problem we had on our homework? A trinomial times a trinomial?
Yeah.
Okay. Now, do you guys know how to do a trinomial times a trinomial? Okay. I'd actually would. We're not gonna finish this one up here right now. I'll say, hey, you guys can finish it up later. But I'll give you the answer for if you choose to finish it up later, or if you already finished it up and you want to check it. So the answer would be x to the 4th plus 8x to the 3rd plus 24 x squared plus 32x plus 16. That would be the answer for this problem.
I did the longest way you could do. I literally did like.
You did the first two, stop, incorporate the third, stop, incorporate. And so you can get the right answer either method as long as you do it correctly. Is that what you did too? Okay. Yes.
So I didn't do that, or I did like this, the x2, like what we did. Last.
So Brady, what you did was when you got to the green. Do you see my step on the green there?
Yeah.
Okay. You added those two parentheses. We need to multiply those two parentheses. Does that make sense? Because originally, Brady, if you go back to the original pink, or excuse me, the original purple, where you have all of those x plus 2's written out, they're all multiplying with each other. Does that make sense? All right, great question. And we'll also have questions on this right now. Okay? Once again, you would go through and do all the multiplying for the trinomial times the trinomial, clean it up, and you would get the answer in the pink there. Let's move on to right below this, okay? So we have a product of a sum and a difference, okay? Here, we're going to have A plus B and A minus B. So are these parentheses exactly the same? No, they're really close, right? What's the only difference?
Subtraction.
One's subtraction, one's addition, right? Before, on the previous 6 examples, they would both be addition or both be subtraction. Here it's one of each. So let's look at what happens. A times A squared. A times negative B, negative AB. B times A plus AB. And B times negative B, negative B squared. Are we noticing it's pretty similar to what we had before when the parentheses were the same?
But the ones in the middle, they cancel out.
But the ones in the middle are different signs. They're still the same value, but just opposites. What's going to happen, though, with the opposites? Abby was kind of saying it. They're going to zero out, right? Okay, they're mathematically just going to go to 0. So what we're going to have here is just A squared minus B squared. That ends up being our answer. We end up losing kind of our middle term, so to speak, because they zero out. They're the same things but different signs, so they're opposites. Okay, I'll give everyone a chance to write that down if they were just watching me do it at first. Okay, so the resulting answer, A squared minus B squared, we can actually call this something special, and we'll use this next chapter actually a decent amount. And what it's called is the difference. What does difference mean mathematically? Subtraction, okay. And are we subtracting A squared minus B squared? Are those subtracting? Okay. So the difference of 2, meaning we have 2 different things, A squared and B squared, and we have 2 squares. Does anyone know what I mean by squares? Okay. To the second power, okay. Now we also use it for numbers like 4, 9, 16, 25, 36. Something multiplied by itself gets to it. So a number squared gets to that. We call those numbers perfect squares, okay? So when we have a difference of 2 squares, we're saying they're perfect squares. The same exact thing multiplied to get it. Because technically speaking, 8, something times something is 8. It's just a really long, like completely random decimal that times itself. It's absolutely absurd. Where A times A is A squared. 3 times 3 is 9. 4 times 4 is 16. So when we have a subtraction of 2 different things that are both perfect squares, we call it a difference of 2 squares, okay? Like I said, I'm just kind of introducing that topic now. You don't really need to remember that name right now. I just wanted you to have seen it right now, so that way when we see it again next chapter, you're like, Oh, yeah, I remember talking about that. Okay, does that make sense? Kind of the purpose of this right now? Okay. You're not going to be quizzing this name. Okay, we're just going to use it later. Okay, anyway. So another example, x plus 9 times x minus 9. Are these parentheses the same? Almost. Okay, I saw someone was nodding her head and then shaking her head, okay? Because at first they look like they are, right? Same number, same variables. What's different, though? The signs, right? One's addition, one's subtraction, okay? They're different operations. So we go through, we FOIL, but what do we think is going to happen? Let's hypothesize here. What do we think will happen before we start? Okay, the middle two numbers are going to zero out. They're going to probably be the same thing, but opposites. Okay? And we're probably going to end up with what we call a difference of two squares, okay? So x times x is x squared. Let's investigate, okay? X times negative 9, negative 9x. What's 9 times x? 9x, are we already kind of seeing what we thought was going to happen? Okay. What's 9 times negative 9? Negative 81. Is 81, a perfect square? Yeah, 9 times 9, we literally just did that math. Okay, and x squared is also a perfect square, x times x. Okay, Elliot, were you going to say that it was 9 times 9?
No.
Oh, okay. You had your hand raised, I thought, so. Oh, okay. So we're going to have x squared minus 81. So we end up with a difference of two squares again, okay? Yeah, Abby. Oh, it so was that time. Don't even at me. Okay. Questions on that? Okay. I think it's really good for us to be able to kind of hypothesize and say, hey, what do we think is going to happen in this problem? And then kind of see if we're true, see if we're right or not. And we were.
Every time it would be like something minus something, or could it be plus something?
Like our answer?
Yeah.
So if we have this exact setup, we're going to have the last one being minus. Because what happens is the 9 times a negative 9 or the b times a negative b, it's going to be a positive times a negative to get that second square. Does that make sense?
Yeah.
Because when we have the same symbol, like on these first 6 examples today, Abby, when we have the same signs, they created the same sign in the middle, but also the same sign at the end. There's a positive at the end every time. Because either two negatives or two positives will turn into a positive. All right, let's talk about some more examples, okay? I want you guys to try number 7 on your own. When you have it or have questions, raise your hand. So, number 7, I saw us end up distributing these. We got x squared minus 5, plus 5x minus 5x minus 25, haha. We end up getting x squared minus 25, haha. Okay, Jaden.
Could we just multiply it by itself or each thing by itself and we get the exact same answer?
So great question. So Jaden's saying, and correct me if I'm wrong. Okay, Jaden's saying, so can't we just see this setup, see the parentheses are the exact same, but different signs, and know we're going to have that middle eliminate anyway. So couldn't we just skip this middle step and say x squared is x squared is x squared, 5 squared is 25, it's going to be subtraction. Can we just jump to that? Is that what you're saying, Jaden? Yeah, and if you see this pattern and you feel comfortable doing that, you can. Okay? Now, I just don't want you to lose sight of what happens in the middle. I don't want you to forget what happens in the middle, okay? Because if we forget what happens in the middle, that can hurt us later in math. So I just don't want you to forget what happens there. But as long as you feel comfortable that you can remember that, I would be okay with that. Does that make sense? Okay, and also accepting that risk of not showing work means that if you get it wrong, you're not going to get partial credit for it, okay? So that's also a risk to accept, okay? So sometimes it can be worth it to show that work just for those partial points in case you get something wrong or make a simple mistake in your head that you normally wouldn't make, okay? On number 8, we end up getting m squared minus 4n squared, right? Because those middles end up falling away, so to speak, because we have m squared minus 2mn minus 2mn minus 4n squared, plus 2mn. And then the last one, we end up seeing, okay, x to the 4th minus 4 as our answer, because we have x to the 4th plus 2x squared, that's a minus 2x squared, but minus 2x squared, and then a minus 4. Questions on any of that, guys? Yo, y'all killed it. Okay, we're going to get to our homework.